So yeah, here we go. So I want to thank a lot Professor Vaidman. Sorry about that. I want to thank Professor Vaidman not only because he's giving a talk, but also because he's been with us for a few weeks now, and it's been great to have him discussing and commenting. So I'm really happy about that. And yeah, finally we hear directly from him, and I'm very curious. You know, Professor Vaidman, he doesn't need much introduction, but he's one of the most important figures in the discussion on many words. He wrote the Stanford Encyclopedia, which you were supposed to read or to have a look for today. So yeah, that's it. Thank you, Lev. He's going to talk about in favor of the many-word interpretation.
Okay, thank you. Let me maybe start with a little motivation, and then I'll maybe do a little even more motivation. This is what I think is a good explanation. You know, although I'm professor in physics in Tel Aviv University, but I would like to believe that the physics works like this. And I'm not sure, I'm not alone. Although Newton had a law which looks different, but really he thinks that it's really inconceivable that in any way matter affect other matter without mutual contact. And he said that no man who has in philosophical matter a competent faculty of thinking can ever fall into it. And maybe even stronger in this term, thought Einstein. If A and B are spatially distant things, then an external influence on A has no immediate effect on B. So this is what I believe should be explanation of everything. And when we look on quantum mechanics, sometimes it looks different. Maybe you heard about the interaction-free measurement of Elitsur and myself. Avi asked me about, I think it was in '91, a question. Let's say we have a bomb, and this bomb is super sensitive. It explodes when any particle touches. And the only interaction with the world of this bomb is through explosion. And you have a task. Yeah. This is the only way it interacts with the environment or anything else. And the task is to find this bomb without exploding. And it turned out that there is a very simple solution. Quantum mechanics allows to do this. But this seems completely paradoxical because I'm not allowed to touch it. The bomb doesn't send anything. So I'm not supposed to know about its presence. And the solution is very simple. It's just a tuned Mach-Zehnder interferometer. If I have interferometer and start and tune it properly, then there is a one port which is always dark if the interferometer is free from objects. So if I suspect that in particular place there might be a bomb, so bomb might be not, I can put the interferometer such that one arm goes through this and send a photon. And if the bomb is there, I might get a click in dark port. When I get a click in dark port, I know that the bomb is in this place. On the other hand, I know that nothing was there. If I would touch the bomb, it would explode. Anyway, it could come to this detector from a bomb. There is no way. It cannot go through, it cannot go backward. So there is a real paradox. And this is the paradox of quantum mechanics if we want to believe in any interpretation whatsoever, except many-word interpretation. Because if I accept many-word interpretation, I know that in a parallel world, there is an explosion. And the picture in the physical universe is that three worlds are created. One with explosion, one with a click in the dark port, and one with a click in this other port. So this is what happened in the physical universe. And physics is for physical universe. So my intuition is supposed to tell what happens in the physical universe. And sometimes in my particular world, there are some kind of miracles. But these miracles are not miracles if we look on all worlds together. Maybe briefly, I will look on another paradox with Tim discussed before. Here we have Grenoble, Hornet-Zeilinger, which have 3 spins in a separate location near them in the GHZ states. And they perform measurement of spin X, spin Y, or, or X or Y in their location. Then quantum mechanics may have this somewhat strange prediction that if they all measure X, the product should be -1. But if only one measure X, then the product should be +1, and others measure Y. So what's strange about this prediction, that if you look on all these equations and we multiply them on the left side and the right side, on the left side we'll get squares, on the right side we'll get -1. So clearly nature cannot arrange something that's something definite. So then we'll fulfill the prediction of quantum mechanics. This really tells us that when they perform their measurement, nature doesn't know what the outcome will be. So it tells us that nature must be random. We cannot, it's impossible that before the measurement, the outcome is known, because if it's known, it should fulfill this quantum requirement, and they're impossible. Of course, there is another possibility, a part of randomness, which I think is very bad. Maybe there is an action at a distance, and in the moment they measure, they change something far away, something which Newton and Einstein are not ready to accept. And this is really, in fact, what must happen here, because randomness is not enough for this experiment. When they measure, for example, X, immediately Anton has a spin which becomes well-defined. If here it's down, here it's down, it also has to be down. Down corresponds to -1. And just before, it was uncertain. We knew that it must be uncertainty. It couldn't be known. So maybe it could be known in one of the places. So look on the place where it's not known, and 2 others will measure. Immediately it will become known. So there will be immediate change with far location. So we have a real paradox. There cannot be known before measurements, so we must have kind of action at a distance, which is not acceptable. Now, how many words resolve this? What can happen? All these things cannot be known before measurement, if only one outcome happens. But we can know with certainty that all outcome will happen. Every time they measure spin, they will get both up and both down. This does not need to action at a distance. So it can be known that all outcomes will happen with certainty in properly distributed parallel worlds. They measure, let's say they get, the first one, Daniel performed measurement, and so he split. There are 2 worlds for Daniel, one spin down, one spin up. Now, then Horn performed measurement, and now there are 4 worlds, because for each one, he can get both down and up. But now, at this moment, in Anton's place, the spin is already known in every world. In world 1, we know it should be down. In world 2, it should be up, and so on. There is kind of non-locality or maybe non-separability in all this story. Somehow there is this non-local connection between up here and down here, and down here. And when one of them changes, then here will be the other one. But there is no action at a distance, because the mixture of these two, up and down, is equivalent to the original mixture of the original GHD state. So when they perform this measurement and they split and there are mixture, so there are now essentially four words. This mixture of all these four words equivalent to what was before. So no change happened far away. So the title was in favor of many word interpretation, and I have several more examples of this kind. The teleportation, I think, is a big paradox, even in the level of quantum mechanics. And I have some nested interferometer with disconnected trajectories. And so there are more cases where many words resolve paradoxes. As far as I know, many words resolve all paradoxes of quantum mechanics. There are no paradox of quantum mechanics if you accept many words. But Uriel sent me a preprint of this paper, which I don't, it looks like it's accepted, maybe he can tell me if it's accepted in Foundations of Physics now. At least this is what Google Scholar tell me. And in this paper, he writes, at best unclear when he described my approach to many words. Only confusing two notions, this can be kind of understood. There is a desperate strategy in my approach to probability, which reveals intrinsic weakness of many word interpretation. Though the only logical way to make sense of Vaidman proposal, I don't know anyone is ready to follow that path. So, so it looks like that I'm, at least for real, I really failed in presenting my view. I believe that many words is kind of by 2 orders of magnitude better than any other interpretation. It resolves all paradoxes, but it looks like it's very unclear. And in fact, thank you for opportunity, because this is what I need. I want to, if somebody will show me where I'm wrong, this will be great. I want to understand nature. Or if somebody will show where I'm not clear, which I maybe hope more, so it will help me to persuade people. I think now for 30 years I'm trying to persuade in many word interpretation. And I don't know if it's because of me or because of somebody of others or all us together. I think it's much more popular today than 30 years ago. So let's change a little the title, more or less the same story. So I will go a little to my view on many words and why I think it's so good. And I'm looking for attacks on my view. And again, I think I need more motivation to present what I want to talk about. Purpose of science, when I look in Google, was explanation of how the natural world works. So I think what I needed to explain my experience. And what I strongly believe, that my experience supervenes on ontology of natural world, and my experience, my memories, and make it maybe less, I don't know, less artistic, but more practical. I think everything in my life, I can think there is a preparation of experiment and outcomes of experiment. And what I believe science should tell me is a connection. When I consider I do something, it's like preparation, I expect something to happen. If science will tell me what will happen, then this is what then science is successful. So I have in my memory records of preparation and records of outcomes. I want connection between them, and the theory should give us this. And what I believe, what I understand, many word interpretation is only deterministic theory, and I think deterministic theory is much better than not deterministic theory. And in this way, people thought until birth of quantum mechanics, I think majority of philosophers thought so. It's quantum mechanics led us astray and trying to believe that there are some uncertainties and randomness. And I don't want action at a distance, which I think there are many people which don't want action at a distance, and many serious people. Okay, so our purpose connecting of records of preparation of experiments with records of their outcomes. And there are two types of experiments. In my life, in my memory, I know sometimes the experiments are really deterministic. So I believe that my theory should tell me definite outcome when I make some preparation. And I do know, at least especially in quantum mechanics, that some experiments are genuinely random, probabilistic. I prepare exactly the same situation and I get different outcome. Even for this kind of experiment, I would like to have a theory. Of course, this theory cannot tell me what will be the outcome because somehow the outcome looks random. But there is something which I can measure, its frequency. So then I want that my theory will give me the frequency of this experiment with randomness. So outline of what I will present. I will talk about classical physics, and I think it's very good. It's local and deterministic. Unfortunately, it's wrong. I will talk about particular situation when quantum physics is very good. It's local and deterministic. And it has no action at a distance. I will also talk about quantum physics when we discuss probabilistic experiments. And here, there are difficulties. I will have to talk about words, and I have to talk about probability, which is not a simple concept. Because really, the nature, I believe, is deterministic, but the probability is something not easy to discuss. There is a proof of Born rule, which I have from Symmetry, Relativistic, Causality, which maybe sometimes later I have slides for this, but I took them out because even what I plan to put, I think I will not have time for it. And what I do want to present is an argument that this proof, which I will not really show, that relativistic causality is not enough for Born rule. So really what I want to talk about is Born rule that we have to postulate. There is no way to prove the Born rule without some postulate. Okay, let's start. Classical physics. Deterministic experiment. I can send a tennis ball on a ball and I know exactly when and where it will end up. I will send it again and we'll do exactly the same situation. I can send maybe I can send instead of this, maybe not a tennis ball, but very fast and small particle. Sometimes it will come here, but sometimes because it's very small, it can go through my wall. The wall has some holes here. And and then it will go here. So sometimes it go one way, sometimes it go another way. But this kind of experiment, I think I still can understand in classical physics. It's because I cannot put initial condition exact to arrange that it will not hit the hole. And when it hits a hole, it goes through it. So I have a theory which explains why I see things which looks random. I look random because I don't know the details. So classical physics, I think, is good explanation. It's local in 3 dimensions. It's deterministic. And the fact that sometimes I see things which look probabilistic, maybe it's just because of my ignorance of initial condition. And it looks like it behaves the same way for tennis ball or for atoms. It looks like we have the same rules. Unfortunately, classical physics is wrong. And maybe one of the simple examples of the type I just discussed here is Mach-Zehnder interferometer with single particles. Granger and Taspek did it like, now it's maybe 35 years ago or something like this. And we can tune Mach-Zehnder interferometer with, let's say, photons or neutrons. And it's when it's tuned properly, it always goes here. My kind of classical theory is that this wall, sometimes it goes through, sometimes it's reflected. Tells me different things. And really, I test, this is really this kind of wall, because if I put the detectors here, sometimes it's reflected. Half time it's reflected. But when I put 2 of them and kind of put it in a particular place, I always get it here. So this is deterministic experiment, which classical physics cannot explain. So I have to, classical physics is wrong. So let's go to quantum physics. I see it's always go here. I have to explain it. And what explain it in quantum physics? Because quantum physics tells that the particles are waves. And if they are waves, so they can make interference. So this is just interferometer, which it was like hundreds of years ago. People under the Mach-Zehnder interferometer is known for long. It's for waves. But even a photon is a wave. So now the quantum mechanics explain why I can tune interferometer for single photons and go always here. So what then quantum mechanics is? I understand it in the way of many word interpretation. First, everything is wave. The fundamental ontology, all is psi. And psi both according to the Schrödinger equation and some relativistic generalization. Now I have to connect this psi. When you look on all psi together, sometimes it doesn't look very like things I see around. So I have to connect it to my experience. And in fact, it doesn't connect to one experience. It only can connect to many experiences. And the way of connection, in fact, I'm ready to be a parasite. People who are not going to this kind of workshop, most of physicists who believe in standard quantum mechanics, at least we postulate that on every measurement, the wave function collapses. So I accept their description. They say there is no problem with quantum mechanics. It works perfectly. They just don't ask how collapse happened. They don't care about this. It's happened. So for me, connection to my experience is through the collapsed wave function of the textbook collapsed wave function. Now, probability, I have to introduce something which philosophers really are not ready to accept. I say that there are many words and they have measure of existence. And measure of existence given by a simple quantum formula. Now, this part is exact science. This part is social science. It's about my experiences. So here the words are not exactly defined. They're vague concepts because that they help me to connect this exact science to my experience. There are some kind of scientific laws about this connection too. And this is what I will talk about, this probability in the end of the talk. So all is psi. Space, I don't play with this. Of course, some people want to accept, and maybe some physics should do this. Not the many-word interpretation. Many-word interpretation should then talk about quantum mechanics. I'm not trying to get from 26th dimension to 11th dimension to 10th dimension to 4th dimension. No, the space 3 plus 1 is given. And this is my starting point. In this space, there is this wave function which is highly entangled. And there is only single universe. The world, it's kind of my concept which I invent to help me to explain my experiences. There is only single physical universe with a single big universal wave function. So this many-word interpretation tells us that there are many experiences. There are many parallel experiences, and they all correspond to this universal wave function. And it's not trivial how to find this connection. What is more or less trivial, it's how to find connection between a word wave function and my single experience. So there are many words, and each word corresponds to a particular experience. If one experience, usually one word. Now, so experience I, word I, psi I, and the universal wave function is just superposition. And I have to decompose this universal wave function. Now, some people think that it's important to start from the right and go to the left, to have some emergence. I have a two-way, and really my emphasis on the other way. I believe that this is true, and I want to find my experience inside this wave function. I don't require, maybe it will be nice, and maybe theory which can tell me my experience will be stronger theory, but I don't think that there is such a theory. So it's enough for me if I can find my experience as universal wave function. I'm not looking for emergence. So, and then I have this measure of existence. I have some measure of existence in this world, and there are parallel worlds with different measure of existence. Now, the concept of word is really very important for here, and there is this Everett word. Everett, which is close to my picture, and I think Everett picture is nice. My picture is slightly different, and Everett picture is consistent. It will be also okay. I prefer a slightly different semantics. For Everett, he has relative states for every observer. And so he divides this, he makes a decomposition of this universal wave function according to observer. This observer have definite states, definite, and then according to observer, we'll decompose state of observer, product state, to everything else in a particular world. I want to discuss a situation when observers, at least humans or other conscious beings, whatever, were not present, and we will not be present. So, and for this, I will take from me or from other observers the concept of macroscopic object, which is wave. So a world is totality of macroscopic object. I need stars, cities. So then I can talk about the beginning of the universe when there are stars and galaxies. So there are some worlds already. I don't want the star in a superposition of being in different places, or supernova exploded and not exploded. Even, so all definition of my world is that every macroscopic object is well localized and has well definite state. Now, it's vague. It's because the concept is vague. This concept is not on the level on physics. It's concept on the level of connection of my experience to physics. So the fact that it's vague, it says it's not a problem. So in my world, there is a product state of object. Every macroscopic object have well-defined state, so it cannot be entangled. All macroscopics are not entangled. We have some other microscopic objects which are entangled, but objects are, they all described by some well-localized wave pattern. Cannot be too localized because immediately after the momentum has very big uncertainty. Everything well localized. Uncertainty principle allows big objects will be well localized for a long time. So, and again, these objects live in 3D. All objects of a world live in 3 dimensions. So the really world is a concept in 3 dimensions, not in configurations. To explain, I want to give you some tale, not this one, this one. A tale of a single world universe. I lived one in a totalitarian country, and maybe some other even more totalitarian country can make laws that you are not supposed to split words. I have a word splitter that currently is not available because of, but hopefully will be available on my site soon. And there are this universe splitter in iPhone, and there are many single photon detectors. They all are forbidden. So let's assume that there is a world without quantum devices, because quantum devices split words. And I want a single word. If I send a particle in the spin up to measure in Stern-Gerlach experiment, the word is not split because the result is definite. So I consider this kind of utopic situation when there are no experiment with random outcomes, everything deterministic. It is forbidden to send a spin X to spin Z Stern-Gerlach device. So in this world, the psi universe and psi world is the same. We have only this product state. All macroscopic objects are in a product state. All of them. So we have this in zero approximation, no particle, but this is beta approximation. We have this there's particles which do not interact strongly. They can be entangled. Only this macroscopic object have to be in a product state. So particles which make atoms, molecules must be entangled. When we have an atom, we have a lot of electrons which are entangled there. So if I talk about the cat or a nail of a cat, the nail has a well-defined position. It's not necessarily center of mass. I can center of number of particles, whatever. If I have to describe where is the nail of a cat, and this is well-defined, but inside there are atoms or even some structures which must be entangled, otherwise it's not they will not be stable. So the same macroscopic object has some relative state inside which are entangled. This is in 3 dimensions. This is kind of entangled state, and really I have to talk about configuration. So we have this psi of this single world universe. We have product state with multiplied again by some relative states which are entangled. But the coupling, when I want to take, I don't know, probably see my, when I want to take a glass by hand in 3 dimensions, go to the glass in 3 dimensions and take it. And if I look on this cat, it's in 3 dimensions. I can look on a number density of this in the region of this cat, and I will see a picture, 3-dimensional picture of a cat. This is a cat. So experience correspond to this geometrical picture, which come out of this wave function of my word. And it's trivial if I have one word. And it's essentially the same like in another interpretation. When I have a textbook collapse, I collapse to this single word in which all macroscopic objects are in a product state. If I'm GRW, it's the same. The GRW mechanism does this. So in GRW, I have again the same story. If I'm in a Bohmian picture, I have this Bohmian particles. These particles sit inside the wave packets. My wave packets are pretty small. So the picture of wave packet, of Bohmian picture, essentially it's the same picture. Or classical picture, if I would say that the word is classical, it's only these particles, no wave function. It's still the description of a cat. It's the same. With classical, with Bohmian, in everything, it's the same description. So connection of experience to in this different interpretation of different theories is simple, and I would say trivial. People don't, in Bohmian mechanics, people don't work hard to make connection to experience. They say that these particles correspond to the cat in points, and then the connection is trivial. Okay, so, but this single word quantum mechanics cannot explain this simple experiment. When I go to this send a particle, a quantum particle, sometimes it go here, and there is observer to make it really macroscopic. Really, the device is supposed to be macroscopic, and when it's a macroscopic device, click or not click, the word is already created. But let's put also an observer. And the observer here has a click and a look on particular detector. So if I have an experiment when sometimes one detector click and sometimes another detector click, the single word picture is not enough. And I cannot explain it by details of preparation because my quantum theory says that I will change something if I'll move a little my source. It's still random. I cannot arrange that it always go to a particular place, even in principle. So what I have to accept is that I need to accept that there are two words together because I don't have other theory. And if this happened and this happened, and I'm not different from anything else, I am also described by wave function, so the observer will be kind of entangled superposition in looking here and looking here. But I cannot accept it in one word. In one word, I cannot be in a superposition. In one word, I have to be having a well-defined situation. So this is described in two words. So I have to accept these two words. I understand that inside every word we have observers which will think that there is only one word. But each observer, if he wants consistent theory without action at a distance, he has to accept that there is another one. So records of preparation of this program give the observers knowledge of existence of two words, but each observer experiences only one word. Like this or like this. So let's go from one word to these two words. Frequently, people discuss the Schrödinger-Cat experiment as two words, but this is a mistake. This is a multi-word universe. There is a one word in which the cat is alive, and there are multiple words in which the cat is dead, because this is a Geiger count and a radioactive, so it's a click in different words in different times. So there is a one really dead cat for a long time and one dead for a minute. So this is not two words. This is kind of a two-word universe. I send a particle and I get these two clicks. And maybe just a few minutes about why these two words is acceptable. I can go to laboratory and to see for particles that there is no scattering between one word and another word. If I make this kind of experiment, I get some statistics. Let's say I look statistic here. If I block one of them, I will get exactly the same statistic. So there is no scattering of particles here. Even if I send the real particles here and here, they will scatter. They will change the statistic. I can go to laboratory and see there is no statistic. maybe it's important conceptual experiment that one can test the many words. It's not in principle. What is a conceptual simple test of many words? I perform this experiment. Now I don't put an observer here because then it will be really difficult for me, but there is a macroscopic device, there are macroscopic devices which people would say that collapse already happened, if people believe in collapse. The result already recorded in these devices, but maybe not too strongly because to test the many words, I need to undo the experiment. Before undoing, I replace my source by two detectors here and here. Then I make this extremely difficult experiment which today cannot be done, which undo the experiment. So if there is here there is a Hamiltonian, which your photon go in and go out. The same Hamiltonian here, but of course, if the photon does not go in, nothing will go out. So if the many words is true, it will be both here, and my device will send, like here, it will send a superposition of photon here and here, and then will be destructive interference here, and all of them will come here. So if I repeat it many times, and we'll see that always here, then I will know that, okay, many words are true, is true. I think I have some time to talk about the meaning of probability of many words, which I think is really problematic, and I believe that my solution of self-location is the only one, at least sensible for me, or sensible at all, but which I understand that at least Aurelius thinks it's a desperate move. So let's discuss meaning of probability in many words. Now I discuss experiment where there are different outcomes which look probabilistic for me, like this one. Now, first I say there is no meaning at the time before the experiment for the question, what is the probability that the observer will be in the word A? What if somebody really wants the meaning of probability of future outcome, I will just openly say, if many words does not provide this, there is no such thing. There will be two descendants, there will be one with A, one with B, and there is no, you cannot ask question who you will be. The experimentalist who started will be both. And there is no, it's a legitimate question to ask who will be, which outcome I will get. I will get both outcomes. So I cannot ask, before the experiment, I cannot ask what will be the probability of the outcome. Both outcomes will happen, and I will be connected to both. So, sorry. Then there is also no interesting meaning for the question, what is the probability after the experiment has been performed? When somebody performed the experiment and got the result, then of course the probability is 1 or 0. I want this quantum probability, alpha square, beta square. So this I cannot get. And I get 1, 0, it's not of interest. Now, maybe there is a question, experiment has been performed, but I don't know what happened. If there is a complete isolation of me, I'm here, the observer is here, he has performed the experiment. We run the experiment. There is a splitting of words. There is one word with this click, another word with this click, and me is here, not connected in any way to one of them. Sometimes people ask, what is the probability that I'm in word A and word B? I say that this question is illegitimate as the question about the future. because I'm in both worlds. In both worlds of, there are two worlds. Yes, the word split because there is macroscopic object like these detectors have different states. So there are two worlds A click, word B click. But I belong to both of them. So there is no, I cannot ask what is the probability for me to be in one of them or another. So now it's here. Let's say when we can't talk about probability. So I'm here and I ask my student to look on the result of the experiment. So my student looked on the result of the experiment. So the experiment ran. The student saw the experiment and then he came to me. These are different words. It's one click, another click. So when the student will come to my office, he will not be exactly in the same state. This happened before. One probably will be different, slightly different positions, different expression, different. He will be slightly different. So I will look at him, and now I also will be slightly different. So now there is a word A, word B, and also there is a word A and word B for me. So I'm in two different words. But he didn't tell me what's the outcome. So it might be that I really know that my student is very good and he always do what I ask him. So I know the quantum state of the universe. I know that it is superposition and student in a superposition and I'm in entangled superposition. I know everything. But I'm in a state of ignorance. I don't know who am I, in which world I'm located. And this, I believe, is the only way to make sense of self-location probability for this kind of special experiment. In other cases, there is no really probability. Only if I arrange this special type of situation, then there is kind of notion of probability in many words. So there are two observers, both are subjectively the same non-trivial answer. One like this, one like this, and both of them don't know they don't know in which world they are, if it's A or B. They're in one of them, but they don't know. So this resolves the problem what people usually name as coherence problem. Coherence problem of probability in many words. It doesn't resolve the quantitative problem. Why I should bet if I know it alpha and beta, that I should bet according to alpha squared. So there are many people who were trying to derive it, and in fact, I also have one proof. This proof relies on symmetry of space and relativistic causality. So if I assume, I think what we see is that our space is symmetric, and we do have relativistic causality. From here, I can get the Born rule. I think more or less the first time is essentially, I think it's published here, and maybe slightly improved or different aspects are written in these papers. And I'm not sure, in principle, I have slides for this, but I don't know when somebody will really push me so I can go. What I want to talk is that I say that it's important that if I'm not assuming something, then I cannot prove the Born rule, because many people made the impression that it can be proved. So the question, can the Born rule be derived without relativistic causality or any other assumption? If I look on standard quantum mechanics, the collapse theory, so we know that unitarity is still, even in standard quantum theory, unitary evolution obeys relativistic causality. But collapse is kind of beyond physics. It's the only thing we know about collapse, that it probably, if amplitude is 0, we never get outcome. If amplitude is 1, we get it with probability 1. We do not know anything else. So, for example, we can invent another rule, which I think many people invent to attack quantum many word interpretation, equal probability rule. If we have several possible outcomes, all outcomes happen with the same probability, independently of their amplitude. The only requirement that it's the scalar product is not zero. The amplitude is not zero. Amplitude is not zero. Now, all non-zero amplitude outcomes corresponding to non-zero amplitude correspond to the same probability. And the probability is just 1 divided by the number of possible outcomes. Equal probability rule. Born rule this rule is consistent with collapse. It is inconsistent with our observation, but it's consistent with unitary evolution of the wave function until collapse. So it cannot be, we cannot prove it if we are in the collapse theory. Now, and maybe just to say how relativity helps, how I can disprove equal probability rule. I can perform this kind of experiment which I discussed before. Particle 50 here, 50 here. So I have probability half to get a click in both sides. If Alice wants to send me a message, she is far away, she can decide to put many beam splitters and like this, and create, instead of 2 words, now 10 words. You see, if she doesn't put beam splitters, then there will be 1 word here and 1 word here. If she does put beam splitters, there will be 10 words, 1 here and 9 here. If she puts 9, if she put the beam splitter, according to this equal probability rule, now 1 over n is 0.1. So she can change probability in both sides, and she can be very as far as we want. So this tells us that if we have this equal probability rule, then we can send signals faster than light. Relativity tells us it's impossible, so equal probability rule is really ruled out. Some more arguments can tell us that it's really can lead to a Born rule. Okay, let's go to the framework of the many words. In many words, there is no collapse. There is only unitary evolution. So maybe one could expect, or one could think that maybe we do not need anything else. And it looks like Everett thought so. And I think several other people, I think, trying to think so. So let's look on many words. We have this unitary evolution as this is kind of basic law about physics ontology. And then we have this second part, connection between the wave function and our experience. And again, this connection has the same property. Amplitude 0, we will never experience it. Amplitude 1, we definitely experience it. So the same equal probability rule is consistent with many words. We can assume that there is a unitary evolution, everything, no collapse. But in addition, there is this equal probability rule. It will not, our experience tells something different. When we look on the results of our experiment, it doesn't tell us, but conceptually, it might happen. In an alternative world, we can have unitary evolution, relativistic invariance, and still this equal probability rule. It's interesting. It does not, if I have super technology like Wigner, to his Wigner friend, he will not be able to send signals faster than light. Only his friends inside the world can send signals one to another. The super technology which absorbs the wave function of the universe cannot do this. I see that I'm over time, but I think I'm close to the end. close to that, I have this weakness of derivation of Born rule. Maybe I should make too many enemies. So let's not discuss this. And if I'll not discuss this, then maybe I just. So if somebody wants to discuss me later or whatever, there are these frequency proofs, and I think they have a serious problem. And the Zurich proof, and it has a serious problem. And Sebets and Carroll, which in fact based on what on my original approach, but I think they have a serious problem. And but the Born rule can be derived from natural assumptions. Again, but you have to make some assumptions. And maybe the simplest assumption, you say, in a classical world, when you make a splitting, parfit or whatever, if you have cloning machine, then it's natural to say that all words are equally probable. I say in quantum cloning machine, it should be like this. But if I split to equal amplitude, it should be like this. And if we have just two things, two properties, if I ask that when in all equal, that our theory should give probability, which are equal when all amplitudes are equal, and we want that if they are not equal, but we in particular word and we split it more, the probability to be in this word or in a splitted word is the same. This is enough really to, again, to prove the Born rule. But again, these are assumptions. So let me just put the summary. The only fundamental ontology of the physical universe is psi. Its evolution deterministic, it has no action at a distance. On the level of the universe, whatever some kind of Gudankian intervention in one place will change nothing in some other place. To explain our experience, we introduce the concept of a world with corresponding psi world in which macroscopic objects live in 3 dimensions. The explanation of our experience requires addition, beyond axioms of quantum mechanics, two laws. First, connection to experience. Everything which has a shape of me is kind of have experience of me. And then there's another one, then when I'm in a particular situation, when I know the wave function and know the amplitude of a different alternative, and I don't know in which world am I, then I should bet according to the measure of existence of these different worlds. And again, if I have kind of very natural assumption, I can prove the Born rule. I have to postulate it first if I don't have any assumption. But I don't have to postulate the Born rule. I can postulate the assumption, or I can postulate the Born. Thank you.
Thank you, Lev. I already have one person on the list. In the meantime, if you want to ask questions, please either you raise your hand or you write your name in the chat. And if you have fingers, please write finger. Okay, the first one is Aurelien, who had a couple of questions. You can ask one, and if in the meantime people want to ask question, I'm going to let you ask the second one later. Or if nobody asks, you can go for both.
Okay. I will do it like that because so you can hear me. I don't know if the microphone is on. Yes.
Yeah.
Okay. So thank you very much for your nice talk, Lev. The thing is, I have first a small kind of short comments concerning the interaction-free measurements that you introduced at the beginning, because you introduced it as the motivation for the many worlds. But really, when I learned that when I was long time ago when I was doing my studies, it was the motivation for me for believing in the Bornian mechanic. So it's paradoxical, and somehow the same experiment can be used for motivating different ontology. But this is an anecdote, okay? The point for me is that I also agree with the presentation of you give for the ontology. Completely I agree with you concerning the ontology of the many worlds. So I saw this ontology like a generalization of the Schrödinger first picture of where you saw the electron like kind of fluid, hydrodynamic fluids of electricity around the atom. And then it was attacked by people like Max Born because it could not explain interference or spreading of wave packet and so on. But Everett and Schrödinger as well, I think he had the idea to say that if this entanglement, which is the key feature, so entanglement with the observer especially. So of course, if you consider this wave function with many variables, you could say you need the configuration space, or you could say that maybe the wave function is a kind of generalization of Maxwell fields in the way it's connecting different points in space-time. So for me, it's fine as well. I have no problem with the ontology, but I have problems with with probability, especially. And non-locality is not so problematic because I believe non-locality. You can give a representation of the Schrödinger equation using a hydrodynamic representation of Madelung, and this is the basis of Bohmian mechanics, as you know. But if you, in Bohmian mechanics, you have non-locality because the fluid is of a pair of electrons, or of a triplet of a particle, like in your experiment, like, is modified by local experiments, so non-locally. So the hydrodynamic picture, which is defended by people like, you know, Chip Sevens, for example, is completely fine for me. It's non-local in that sense, but there's no yet probability. And that's the real issue for me. The probability is the core of the problem, because you say that you have a kind of illusion of probability. So I apologize because the paper that you give some code about my paper. Thank you, but first I apologize because this paper was not to criticize your work, but to present a different perspective. And so this is a point. I will probably change that in the next version. But the thing is that the probability concept for me is problematic because you have you focus on one aspect of the problem, so the epistemic probability. But the epistemic probability is not everything. As you know, probability is a Janus concept. You have epistemic versus statistic, frequency if you prefer. So the epistemic probability is well discussed in your experiment where you have the student in the lab and things like that. And I can disagree a little bit maybe with if you can actually assign probability before or after. This doesn't really matter for me. But this number that you assign to the experiment is not yet a statistical frequency. And then immediately you have a problem when you start thinking about this issue. And I don't think that you solve it really, because if you go back to this picture of the electron, as I say, generalization of the electron as a waveform, as a generalization of the classical picture of Maxwell, where you have a field which is split in different regions of space, for example. Immediately you see, okay, you have a hydrodynamic picture. You have a wave packet before being split, then it's separated, split into two wave packets, E and B. So you have two wave packets. You have, in that sense, somehow two electrons. But now you say, okay, you have entanglement. So you can propagate this entanglement to observers and to students and things like that. That's great. But you have different part of the wave function, but you don't have yet a statistic. If you need the statistics, you need to repeat the experiment. So you will do, for example, n times the same experiment. So you will have a statistic of particles, and you will say that this probability, that you would like to assign a frequency which is equal to, you would like that your frequency is equal to the number that you assign to the branch. And the problem is that you didn't give any clue that this is really possible, because in Bohmian mechanics, for example, it is possible to do it because you have something more than the wave function. You have a particle, and the particle is giving you a configuration which is existing independently of this two-wave packet. You can say, okay, independently of the knowledge about the wave function, I know that my particle is left or right. But no, this configuration is giving you a kind of fine graining information that you don't have in your theory. You have only two-wave packets, and nobody will say that in classical optics you have probability. So I don't think that you can generate probability in your experiment as well, because it's simply a classical wave propagation. Even if this is in a complicated configuration space, it doesn't matter. You don't have this discretized element that you have in Bogdan mechanic. And in Bogdan mechanic, you have also another issue. And people like Valentini knows it very well. You say the probability is equal to Born rules, but why? Nobody knows. This is a problem which is related to the initial conditions in the universe. People like Goldstein, for example, they say that this is about typicality, if they want. But the typicality cannot be defined in a univocal way. So you have a big issue here, I think, because you cannot say that you have a probability, you have only a fluid, hydrodynamic fluid, and you cannot say that is an element existing independently of the wave, which can define objectively the probability. This is for me the big issue. And yes, and the rest are probably details, and I will let, because there are so many, it's very complicated topics in many words of interpretation, and probably the people would like to ask other questions. So yeah, that was my main points, I think. Yeah.
I have to say that I have difficulty because
What's my song?
You said so many things, so I don't know which one. Maybe just first. Let me discuss. I understand that you think the main thing it's probability. So let me just present a little the probability problem. In the many words, there is no meaning to probability. No probability. So there is no randomness, there is no ignorance. Probability of something to happen goes A and B happen. Now, we had an observer and the same story. And in different theories, for example, like you discussed Bohm. Yes, conceptually, it's much easier to discuss probability in Bohm because here it's clear what we're talking about. In Bohm, there is ignorance probability. We don't know where is the Bohmian particles. Here we have a beam splitter which reflects only 10%. Then if the Bohmian position was sitting in a low part here in the 10%, then we'll go here. Here, so, but in many words, we don't have it. So in many words, both happen. There is no meaning, probability of what? We have this happened and this happened, both happened. And even if I know everything, I know the wave function, I know the universe, everything about the universe, I still cannot discuss probability. So then the only way I had this situation when it was an experiment, I was moved here and here. And after this special case, after the experiment finished, and I know the wave function when I'm awake, but I don't know in which world am I, then I can talk. Then I can talk about probability. So this is solution of the coherence problem, and I failed to see where you was trying to say what's wrong about it. If you want to tell me that I don't give here a Born rule, the main thing about Born rule, what I want to say, I want to postulate it. I want to postulate the Born rule, and I think every interpretation postulates it. So if I many work postulate it, also it's okay. There is no problem. Now my postulate is only about this special situation. Only then I have to postulate. It's also have to explain because all my knowledge about quantum experiment tell me that they correspond to a Born rule. So this is experimental fact. So I need to introduce a postulate that my probability give me Born rule. And the statistics, all this frequency, all this discussion, philosophical frequency never, if I have a law that my fair coin should give 50%, there is no contradiction whatsoever that 1,000 times it will give me tails. Moreover, if I will repeat Google times my experiment, clearly there will be a run of 1,000 which 1,000 tails. It must happen. This is what I'm trying to answer your maverick objection in your paper. This maverick cases should happen even in a normal case. So, is there any other question? Can you, instead of putting all questions together, give question one by one, and then I can be able to answer them.
So, no, the point was only about what you say. It's about I cannot see how you can define a probability. You have only intensity, and the degree of, you said what you call.
No, there is no probability. N.
Yeah, but then you have no probability if you have no ignorance.
What? Yes, there is no probability.
And then
the word is deterministic. There is no probability. But for us, inside the word, there is illusion of probability because sometimes we don't know in which word they are. This is ignorance. We don't. There are parallel words, and these words have different. There is no reason to consider them on equal footing. Some of them are kind of bigger than others.
Why?
And there is a meaning for bigger than others because some of them can interfere stronger than the others.
Yeah, they can. In general, in this experiment, they don't. For example, they don't. In general experiment, you have the coherence. You don't really. You take Stern-Gerlach experiment. You have different branch. You have different. You could add. You can assume weights to the branch, but it doesn't really matter in a real experiment. Okay, without using strict these tricks like the sleep, what you said. Use this pill story very often in your discussion when you're defining probability, the sleeping pills, or without this trick of the interferometer, this kind of things. At the end, it doesn't really matter. You have branches, and you can assign a number to the branches, but this number is not a number that you can use for weighting your ignorance, even the subjective ignorance. It's simply an intensity of the fluid for me. So how can you be sure that, and initially it's not univocal. You have many ways to defining this intensity. As I say, it's from the work of Valentini. So
if I will define it differently, there is this natural property that if I assign probability for a particular word, I have, let's say, word A and word B. And I say word B has probability 0.8. Then I take this word 8 and split it to another 4 parts. I expect that the sum of probability, now I have A and 4 other words. I expect that these 4 other words will have still probability 0.8, which I think is very natural. And this tells me about this is if they will not be 0.8. Then I can send signals to word A because I can change probabilities there. The total probability is 1. So there is a very natural situation that if I split the word to more, the probability of splitted word should be equal to the probability of the word which I started with. This is very natural, and this tells me that from here I have to get a Born rule. So I can also kind of derive a Born rule, which I say I really, again, I can also derive the Born rule. I go to laboratory, I go to scientific papers, and I see that they correspond to a Born rule. All experiment, I read description of quantum experiment, and then only later I read the result. And I see that all experiments fit the Born rule. So I say it's just experimental fact. It's also good enough. So there is no, and it's natural. It could be, otherwise it would be some contradiction. But people have to put some physical laws. So there is one physical law, Schrödinger equation, and second physical law that if there are different branches, the branches, definition of branches, it's just Schrödinger equation. But definition of, if I find myself with one branch or another branch, Schrödinger equation doesn't tell me. So this has to be added. So like in standard quantum mechanics, there is a postulate. And so I have, I have no problem with this postulate, and I think it's of some interest to add some kind of argument why this postulate is better than others. But even taking as a postulate, and then the many word is great. I don't. The first thing, we have this coherence problem to understand what is the meaning. And here I just say openly, there is no meaningful probability for outcome of future experiments. Make no sense. You cannot ask this question. Many word doesn't allow this because all outcomes will happen. So there is no such thing. But after the measurement, you might not know where it's, so in for practical purposes, this might be useful. Moreover, usually probability is for betting. Since I'm bet for my, the rewards will get my descendants. And the descendants might have this probability because they will be after the experiment. So I do it for them. And usually what I do is I do for my future. Out of me, there will be many of me. And I do it for all of them. They would like me to do this. So I do it for them. So then I have this behavior principle. I will bet as if there is a meaning for probability for future experiments, even though I know that there is no such thing. Essentially, I will care more about my descendants who are in the worlds which have bigger measure of existence, because they exist more. So I think it's natural that I care for them more than from others.
Yes, thank you. I think probably we could discuss very long about that.
Yeah, I think you can continue after. There is a comment from Jean, but so far no other questions, so you're gonna have time. Jean, if you want to, yeah.
Okay, I know Lev and I won't agree, so I will try to make a comment for the others to explain what my objection is. If there is first of all, if there is an experiment where there's probability 1/2 for each outcome, then and I decide myself to do this experiment many times with the same wave function, starting with the same wave function, preparing the same experiment, if you wish. Then after one time, I have 2 descendants, and after 2 times, I have 4 descendants, etc., etc. Now, of course, some of my descendants will always see, let's say, the cat being dead or the particle being up, whichever way you want to phrase it. And of course, after 1,000 times, those descendants will think that quantum mechanics is wrong. Because if I throw a coin, of course, it's a possibility that I have 1,000 times, let's say, head. But of course, if it happens, then I have to, it's rational to think that the coin is biased rather than thinking that I'm seeing an improbable event by definition of probable. So some of my descendants will conclude quantum mechanics is wrong. But the vast majority of them will continue to believe in quantum mechanics because the vast majority of them will see on statistically half dead cat, half live cat, or half the spin up, half the spin down. Okay, good. So in that sense, you can give a typicality argument to say that in a typical sequence of worlds, sequence of descendants, quantum mechanics is okay. But now suppose the probabilities are, let's say, 1/3, 2/3, anything different from 1/2, 1/2. Then at each experiment, they still have 2 descendants, and then 4, 8, etc. But then the vast majority of my descendants will see statistics. One of them will see up and down, so on. They always will see statistics with the vast majority will see more or less 1/2, 1/2. But they should see 1/3, 2/3. So after a while, the vast majority of my descendants will be rational to stop believing in quantum mechanics. Now you're going to reply to me with the case of existence. I don't understand what that means, so we can't communicate about that. I'm sorry for that. I'm just explaining what my objection is. I explain it to Paul, and Paul says there are objective probabilities. You say there are no objective probabilities. So, okay, never mind. I mean, to me, that's the clear-cut way to explain why the many world does not account for the statistics. I'm just counting the number of descendants and what they experience. And I say their experience when the probabilities are not the same, and the world splits into two at each experiment, each repetition of the same experiment cannot account for the statistics. Okay, that's what I think.
So, John, first, you agree with me that then, although I'm not sure, even this is, that if all branches have equal probability, and I think this is essentially the situation, if all branches have equal amplitude, then I say the situation is the same like in classical things. If you're classically split many times, then the natural thing is just to count how many like this and how many like this. So here are we in agreement. Now we put in a situation.
Not exactly, because there'll be sequences of words or sequences of descendants that will not agree with quantum mechanics. But okay, that's not the main point. That's not the main point.
Again, I think even when you have a coin and you look on it very carefully, and this coin look very, very natural and okay. And so you throw it 10 times and it's 10 times heads. Then you look on it again and you look that it's fine, then you still believe it's just your luck. If you have other reasons to believe that it's a fair coin, even after 1,000 times, you might believe that it's just luck because you analyze your coin and you have no any scientific reason to believe that it should be found. And if it might happen, the probability up to the 1,000 might happen. If you have, if you believe in science and you understand the physics of throwing your coin, you believe so. So the same about quantum mechanics. If people see quantum mechanics and they see that the Born rule explains them everything, why sky is blue and why all the devices working.
If it happened 10 times, I might believe that it's chance. But if it happens 1,000 times, then I will believe that there's something fishy.
Let's go to your main question. Now you consider this case of the measure of distance is 1 to 2. And then suddenly you again look on this number. And I tell you all the time, the number, this is not important. What's important, that I will get a correct picture if all amplitudes will be the same. So for example, I can make in your experiment, when you have this 1 and 2, I will do the following. For all words in which it's 2, I will add another experiment, which give me head and tails, which is not important. But it will make splitting. So the number of words now will be bigger. But now in every word, the result, they will have all equal weight. And now your statistics will work. So even in the quantum case, if I have unequal weights, and I will take these 2 words, if I have 1 and 2, I will split the 2 into 2 equal. So I have now 3 words with 3. So if in the moment all words are equal, statistics is okay.
Yeah,
and again, there is your idea. You say you don't understand what's measure of existence, but to say that you have, I have a beam splitter which reflects only 0.1%. And so I have a very improbable result for reflection. This is very improbable, and this is very probable. And why should I consider these 2 words equal? They're not equal. They're different. What I know that, for example, I can split this one in 9 times, and then they all will be equal. And it doesn't happen for this one. If I split this one 9 times, they will not get 10 equal words. Here I will split this one to 9 times, I will get 10 equal words. So it's very natural to consider this one as 9 times heavier as 9 classical words, because I can perform experiment which doesn't do anything important, just splitting. And then I will have 10 words. These 10 words I will consider on equal footing, and then just and then all statistics will work like in a classical.
Yeah, of course. But then now you're saying that you split the number of words that you have after an experiment does not depend only on the Schrödinger equation, but on the coefficients that you get in the expansion in the basis, right? If you have a probability of 0.9, then you have 9 words and 1 word if you have 0.1. That's a different theory. I thought
No, that's not a theory. It's the same theory. I just to make my kind of
2 words or 10 words?
No, I perform the different in the same theory. I just decide to make. I have to make demonstration, and I have to make an experiment. So I will make my experiment. When I perform experiment, I arrange all kinds of situations. I want equal amplitude, not equal amplitude, and here I will kind of force myself to create all outcomes of all words will be equal amplitude. If I will assume this natural thing, which I told you before, that I expect probability of a word the same like probability of all words which I split there, the sum of probability of a word which a split supposed to be equal to the probability of this one. This is this is very natural. But it will be very strange if it will be otherwise. If it will be otherwise, I can send signals to B, as you understand. Because if I don't do anything, it's 0.1. It's 0 now, according to, I split the number, and I will change. The total is 1. If I splitting here will change the total sum, then this one should change. And this is far away. So then from this no signaling, I can prove that it must be like this. But again, I just postulate.
Okay.
So thank you. Unless I don't see your, yeah, there is a raised hand. Dustin, it's your turn.
Okay, hi. Yeah, thanks, and thanks very much for the nice presentation. I would also push back on various points, but I just want to focus on a rather basic one, and maybe Aurelia has mentioned already something in that direction. But you had this slide about the rho density derived from the wave function, and you showed it similar with Bohmian mechanics, only that you have these bubbles around the particle positions. And can we agree that this picture is not really accurate, because the wave function, even of a cat, is defined on a very high dimensional configuration space. So you would have a density on a very high dimension.
No, this is what I said. When I talk about cat, I will first, and there is a freedom. The one thing, for example, I can consider a center of mass of a cat. And since I don't like the density or mass density, then instead of center of mass of a cat, I will consider the center of number. I will consider all particles, and I will think center of a cat, like I will put position of all particles of a cat, and then I calculate its, and then I'll calculate its center. My claim that this center, I can rewrite my wave function. I can wave function of all parts that are about 10 to the 22 particles in the cat, 10 to the 26, whatever. So still, there are many 9 times 3, because 3 dimensions. So, but I look on vector, so I have this 10 to the 22. I can write it like, so now I'm teaching analytical mechanics. I can change my coordinates. But also in quantum mechanics, I can write my wave function as a function of x1, x2. I can write it as a function of x1 plus x2 divided by 2. Here is a function of sum of all x's divided by the number. This is my x position.
But this doesn't This doesn't describe the cat that we see. I mean, a dead cat and an alive cat could even have the same center of mass.
If I want to throw a tennis ball into the cat, if I know this position, this will be good enough. I throw my tennis ball into this point, I will hit the cat. No questionable. So it's tell me where is the cat.
No, but it doesn't even distinguish necessarily between a dead cat and a living cat. They can have the same center of mass.
Yeah, but now, of course, now later I can discuss the one nail of a cat. It's also macroscopic. So I will describe nails or whatever. But now let's discuss. You say that it doesn't work at all. So let's discuss just.
Oh no, I didn't say that.
So what you said, I need a configuration space and whatever. I don't. To say where is the cat, I need just the center of particle. Sum of xi divided by number, sum of yi divided by number, sum of zi divided by number. Give me a center of a cat. This is where I want, if I want to catch my cat, I have to go there. Now I want to understand if the cat is lying or sleeping, whatever. I need, I have to discuss. To look on a hair or other things. They're all kind of, all these things are pretty in a word that what I call macroscopic. What I cannot distinguish with my devices, with my eyes, it's microscopic for me. I'm ready that it will be entangled and whatever. But if I want to grab the cat or run out of the cat, so I have to know where the nails of the cat. Some cats are dangerous. So I have to know where is the nail of the cat. And this is what I have to know. And this nails of the cat I will describe in 3 dimensions. And in my world, the nail of a cat will be in the product state with everything else. It will not be entangled with anything.
But that's probably not true, no? I mean, that's probably not true. The position of the cat's paw will be entangled with its brain and many other degrees of freedom.
No, this is the whole point. When the cat has definite space, definite position, I can put this, again, this is a question of semantics. For example, Schrödinger cat. I will say there is no such thing like Schrödinger cat. It's a wrong semantic. I think Wallace might agree with me. Because for me, a macroscopic object should be, or like cat, should have well-defined position. There is a meaning for dead cat, and there is a meaning for a live cat. I can talk about particles in a superposition of states corresponding to death, and particularly in states corresponding to a life, but I will not call it superposition of my cat. In my one word, the cat is alive or dead. It's never in a superposition, because
then this means the split.
What?
Then this means the splitting into the multiple worlds depends on whether you look at the cat's nail or his tail or his head, or for every whatever you distinguish.
Definitely, everything macroscopic is not entangled. Now, my definition of what macroscopic is vague. I can put a very more fine grain, less fine grain. I have to. The word is not. Some say there is 1,000 words, and some there are 1,000,000 words, because they will make it more fine grained and less fine grained. But it's just definition. In a word, everything, all macroscopic objects, objects which I interact with. When to live, it's to interact. So everything to interact is kind of macroscopic. When we live in macroscopic world. So everything which we interact with have to be well localized. Have to be in particular state. So in a word, all macroscopic objects are well localized. Now what I write here, this row is just, this has nothing to do with this. It's just, but now in this particular single word universe, when I write this shape, it will be exactly the picture of a cat. Nothing fun. If this cat will see kind of superposition of flash here and flash here will start moving, whatever, it will be kind of then there will be more words, and then I will put one word get in one position, another word in another position, and every word, the picture, the three-dimensional picture drawn by this formula, will give me just the shape of a cat.
Okay, now I'm not convinced, but I understand much better what you mean. Now, I would also make the objection, although maybe that's a bit nitpicking, that where in the theory, where does the theory tell you that these coordinates are somehow have anything to do with like positions in three-dimensional space or anything like that?
This is,
There's
as I
always
said, space is given for granted. If I like classical mechanics, we are not made out of particles in particular places, but if it would, I think it would have a good description of everything around. So I have a three-dimension, I don't play with it. I don't, Wallace believe in it, field theory, whatever. I believe that we have to understand fundamental problems of quantum mechanics because it has measurement problems. And in many words, solve it completely.
Yeah, it's just treating the whole formalism of the wave function as if we were talking about configurations of particles, only to then say, well, there are really no particles at all. But this picture of, you know, a configuration space of positions of n particles in three-dimensional space is somehow conceptually always in the background. I'm not saying that this is inconsistent, but it feels to me a tiny bit dishonest.
Well, still, now, there are two things. One can think about configuration space. In fact, even classical mechanics, I can make a configuration space, but people say, no, it's three-dimensional because you don't have to. I can see in Bowman mechanics, I can see it's a one point in the configuration space moving. But I also can see like endpoints moving three dimensions. And what
Sure.
I want now, and I cannot do this when I consider all particles in many words correctly. But all things which are relevant for my life and for my experience, all this I can put in three dimensions. So when I look on a Born wave function, all macroscopic objects are in three dimensions and they're essentially very close. Like here, you see, this is my wave function, my wave packet, and this is a Bowman, and I cannot really distinguish. This is a microscope. I cannot distinguish between this position and this position. So what's the difference if I describe all with these points or with these clouds? No difference.
No, but okay, but then this goes back to the first point that I don't think this picture is accurate, except if you think that, you know, the wave function, all degrees of freedom factorize, which is not true for macroscopic objects.
In the world, this is how I divide. I have this universal wave function and I decompose it to the sum of world wave function. This is the property of my world wave function. My world wave function, by definition, macroscopic object is well localized.
Yeah, but what you have drawn is as if the wave function would factorize for all microscopic degrees of freedom, not just for macroscopic.
No, but macroscopic are not factorized. As you see here, for example, if I look on a particular cell in the cat, it has some molecule. This molecule has entanglement between atoms. And this is quantum state, entangled state of atoms of a molecule. And it's multiplied by the center of mass of this cell, which is more or less, if it's became macroscopic, maybe several cells, hair. I look on the hair of a cat, then clearly inside there are some things which have to be entangled, otherwise it's not stable.
Sure,
So
but that's what I'm saying.
Not microscopic, but when I touch the hair, I make an interaction on average time with this variable, with this position. I don't look, if I have an electron kind of accelerator, I can kick some entangled particles, but usually in my hand, I will never do this. So this explains my experience because all what I do in three dimensions. And
yes, but you cannot draw these little clouds these yellow clouds around every position of the Bohmian particle. Unless you assume that the wave function completely factorizes into three-dimensional wave functions for every single microscopic
to be
degree
more
of freedom.
careful, yes, because this is the tale of a single world, the real world. In the real world, we do have entanglement, and then in entanglement we have this Bohmian. We not necessarily don't have a product, and the Bohmian might be. But essentially, no, I'm not so sure. No. Even in entangled, everything is very local. All particles are very localized. I don't think there are problems.
In Bohmian mechanics, yeah, the particles are localized. But here,
okay, you say again. Here there is some rest. There are neutrinos or other things or whatever, or just particles which I don't make interaction with them. And they may be in a big wave function, and maybe it has some Bohmian particle which sits someplace. But anyway, this is something which is not important to me. The particles of a cat here are all more or less here. So there is entanglement in the atom to make atom stable, and there is maybe entanglement in photons coming here, coming to other planets, and electrons. And so,
yeah, I understand the idea. I thought we could agree on the basic point that the illustration is not really accurate. You can't give one cloud around each particle position, because the microscopic degrees of freedom will be entangled even in a single world. Doesn't mean that the whole thing doesn't work, just that the picture doesn't seem accurate.
Again, if this picture is a microscope inside, then it has to be. Yeah. Okay, I accept it.
Okay, thanks.
There is a comment by Paul, if I saw correctly. And then we can go back to Aurélien, who has another question.
Well, this is just really to press Dustin's point a bit further. It's the yellow fuzzy balls which are a problem, because they're indefinite states. It seems to me that it's long seemed to me that a problem in many worlds is it's not recognizing that you have to give an account of indefinite states at some level. I mean, if it's whether it's microscopic or macroscopic is not the point really. I mean, if you've got anything like one of those yellow fuzzy balls in your ontology, you've got to tell me what the fuzzy ball is. And unless you've got a way of telling me what it is, it's other than it's just wave function, then it does seem that the sort of the wave function realism just is breaking down when you ask, yeah, okay, you're giving me a account of where the cat is, but what's it made of? What's the stuff of the cat? And it comes down to the yellow fuzzy balls, and that seems the problem.
First, the only ontology is the wave function. There is nothing else. The fuzzy ball is this.
Okay,
now, wait. If you go to experimentally to send electrons, maybe before when they were classical, they thought that they sent some balls. Now they understand. They send wave packets. This is
yeah, okay, but a wave packet. What is a wave packet? When it comes down to it, it's an indefinite object. I mean, it's not a question.
Again, you say, for example, when I did put here about teleportation. Why teleportation is possible? Because when I teleport an object, I do not teleport the particle. I teleport only the wave function, the shape. I am a shape. I'm just a wave function. I'm exactly, you say this, you want some particle, half? No, what I want is just particular picture. The shape is the whole story. So it's this way, and this has particular, and this is the shape, the ontology of the wave function. I'm just particular wave function. And the cat is particular wave function. The electrons of cat and my electron are the same electron. What's different is the shape of the wave function. This is really the reality. The reality is the shape. So when we have particular shape, this shape will continue behave in different ways. Because, and so this is me, and this is cat, and this is table, and so electron is much, electron is a degree of freedom of this shape. Now the real thing is that things, objects, which we are used to, are just patterns. So the pattern is the whole story.
I mean, all I can say is, there still seems to be a question: it's a shape of what? What is a shape? Is it a shape of? It's a shape of a material object existing here in front of me, and what's it made out of? And then I come back down to the fuzzy yellow balls, and I don't know what they are really. I mean, I don't have an account of how they can exist somehow. But
people will say there are some strings or membranes or whatever, and the particles are particular excitation of them. So now I say there is this wave. Even with electromagnetic wave, it's very unclear. There is this step. It's not a wave of anything. I can see a wave in the sea. It's a wave of molecules of water. But then even the electromagnetic wave is conceptually difficult, and the quantum wave is even more difficult. And everything, the only thing that exists is this quantum wave of this quantum state of quantum wave. It has a shape. If you draw with a picture in 3 dimensions, it will have this kind of shape. This is what it is.
But I mean, the quantum wave, as you're calling it, is fundamentally different in as much as, I mean, if you talk about an electromagnetic wave, you're talking about definite field values at points and space-time and so on. But what you're calling the quantum wave is something fundamentally different, which standardly is taken so that the squared amplitude gives me the probability that I'll find something.
There's no probability. There's no probability. There's no such thing. There's no such thing. There are many parallel worlds. And sometimes you don't know in which world you are, so you see illusion of probability. All it sees is there are only this way.
My point was really, I mean, was that the yellow balls are made out of a sort of wave which is fundamentally different from what you're talking about, other sorts of waves. I mean, all I can say is, it's standardly taken to involve something like probability and
all what it allows me.
But anyway, I don't think I can say. I don't think I can say any more.
This wave allow me to draw this picture. This picture will correspond to familiar object, and this is my correspondence between this abstract wave of whatever it is, or whatever is not, to object, because I will see familiar shape. This familiar shape will move in time in familiar way, so I will follow. So this pattern is a cat. It's a pattern of this thing which has, it's not any substance. It's not water. It's not molecule. It's not whatever. The pattern is the cat, and the pattern will be kind of again. I need some also degrees of freedom. My electrons, protons, whatever, it will be degrees of freedom of this kind of, which will allow me to define this kind of wave. Wave of electrons, that is proton.
Maybe I could propose that next week we could sort of start from this point, because I sort of have the impression, Lev, that contrary to some wave function realists, you seem to believe that you don't have to recover the three-dimensional level. You can explain everything just with the wave function. So you're kind of eliminativist about molecules or about cats or about tables, while some people in the debate seem to believe that they really have to like explain how the macroscopic world emerge out of the wave function, but they don't want to be eliminativist about the macroscopic world. You seem, as far as I can understand from what you were saying now, it seems that you really want to say there is no such a thing as a cat that is different from this pattern of the wave function. I'm not saying that you are the only one saying this, but it seems that there are also other people that want to be something else than eliminativist about the macroscopic world. And I think that if you are not completely eliminativist about the three-dimensional ontology, leaving alone the problem of explaining the 3D, how the 3D emerges from the multi-dimension, which is probably one point that was already raised. But even if you don't have this problem, I think there's still an issue concerning what, you know, if you eliminate everything, there is the problem that Paul was trying to point to, which is, you know, then what's the cat made of? So I think the reason why people do not try to be eliminativist, like Albert, as far as I understand, is that they want to explain that the cat exists, but yet it emerged from the wave function. So they'd rather try to explain this relationship, while you're saying, no, there is not such a thing as a cat. The cat is just a part of the wave function. And did I understand correctly this last part?
Cat is a pattern of the wave function. No question about it. There is no any mental additional things or whatever. So it's particular.
You see that one might want to say more. One might want to say, yeah, there is the wave function that is the fundamental object, and the three dimensions emerge somehow, and we live in a 3 dimension. Still, the wave function is the most fundamental object. So you see, there is a difference between saying the wave function is the only thing that exists and saying the wave function is the most fundamental thing that exists. Namely, it's what explains everything else. It's what grounds everything else. Whatever you got, it's that there seem to be two different views. In one case, you seem to be eliminativist about everything that is not a wave function. And someone might be puzzled because I don't feel like I'm made of a wave, out of a wave. I might be made of something that is explained by a wave. That might be okay, but I'm not a wave. That's my gut feeling. But yeah.
I have no problem to be a wave, and I don't want to add my Bohmian particles, because then I have to believe in non-local action at a distance.
Yeah, that's another issue. And
but this is exactly, I think, first is the most economical. There's nothing else. I don't need to introduce anything else. So I don't, and so I really, some people say there is a mind-body problem and there is something else. And some people say there is a soul and other things. No, I'm complete materialist. When my material is just this quantum state, which is convenient to talk about as a wave function, because then I can draw the pattern which show me familiar objects. And this is how I make connection to familiar objects. Particular shape of this quantum wave is me, and cat, and so on. And I don't see any reason to add anything else.
I don't like wave function realism, but I think there are people that want to express this view differently from the way you do. So just from from an external point of view, I just wanted to point out that some people disagree with this approach you have, and they might be good. They might have good reason, even if they, they're not Bohmian and they're not. They like many words maybe, and still they want to have a different account of what how the word emerged out of the wave function without being anti-realist about the wave function. And I think if you go this way that is different from yours, I think you might have the problem Paul was mentioning, namely that you have some sort of middle level that is neither the cat nor the wave function, in which you have those objects that have fuzzy, like the yellow picture. but I didn't want to talk too much. Actually, as a chair, I shouldn't have done that at all.
Just to mention that frequently wave function realism, people mean this really Hilbert space realism, which I think, and Dave Albert put it very strongly, that by the bullet, that we have this quantum Hilbert space, quantum state in the Hilbert space, and this is the reality. I don't see reality in Hilbert space. I see reality, with reality connecting to me, it has to be in 3 dimensions. And I found this 3 dimension in this quantum state. It's very difficult to find it in universal wave function, but it's not problematic, but it can be found in the world wave function. And since we live in particular world, there is one, for example, this kind of Bohmian, not Bohmian, GRW people who have this GRW mass density.
Yeah.
Their mass density is this thing. There is no any, this is exactly this. Of course, they have, and here I talk about single world. It's the same story. They have mass density. It doesn't have to be a mass, it should be a particle density. And they say, this is reality. Mass, when the mass is real. When it's a wave function, it's not real. There's no difference. If mathematically I can define the same geometrical shape. So it's the same story. So I don't need any addition.
People in GRW recently talk about matter because mass is not really correct, and also they also have reasons why they moved from particles to mass. So there was Philip Pearl somewhere there, so I shouldn't be the people talking about that. Probably. I think there are reasons why they've done this.
He doesn't. For him, he believes in GRW, although he started this whole story. And for him, it's just the wave function. I think the ontology of the wave function is completely reduced.
But not
he doesn't believe in ontology of multiple wave functions. He believes that there should be one corresponding to a one story. But from the ontology, as I believe that his GRW is just the same story. It's the tale of a single world universe. I believe he should sign on what I said.
Yeah, just like Girardi seemed to think that there were a lot of reasons why we should talk about mass.
Unfortunately, I cannot ask him.
Yeah, that's right. But so I have to say sorry a lot to Aurelian because there's not going to be time. But Alberto, he didn't talk so far, so I'm going to allow him to. If he wants to, otherwise we can go next week.
The place of Aurelian, if he's first, he should go.
You do you guys. I don't want to.
Then keep the order.
No problem.
there is time for a small question. Otherwise, we have plenty of time next week. We have 2 hours, as you like.
For me, it's okay. For me, it's okay. Next time, if you want.
So, I think Alberto, if you had questions, ask now. Because
I can ask the question very fast. But first of all, thanks for the talk. I find intriguing the observation that actually to assess dead or alive, we use microscopic in 3D. That's empirically accurate, although medicine has some certain issues in certain cases on whether to and how to assess that. And also is interesting the idea of introducing many worlds, and then the lack of information is about not knowing on which world you are. I follow that. But then you say the lack of information there is of the same nature of classical probability. And there, I mean, the lack of information to know in which world you are, because you said that lack of information is of the similar nature of the lack of information when you have probability in a classical setting, okay? And I think that needs to be analyzed. And the question is if there is ever more formal mathematical description of all these steps and how from these steps you recover the distribution of a specific quantum experience. Because intuitively one would think that to go to the last step, to reconstruct, you need some form of phase-weighted probability, which is not of classical nature. And that might be where, again, comes in some element that brings you back in a way to the quantum debate in the other interpretations.
So when I talk about classical probability or classical cases, it really, I didn't explain it. In many words, we consider situations and perform some experiments. And then I believe that the world split, and so there are several descendants. And I say that the probability is for descendants might not know in which world he is, and so he will put some value, weights, bets on which world he is. And then one can consider a Gedanken classical situation, that there is a machine which takes a person and make 5 of them identical, the identical memories, identical everything, put in 5 rooms. This, of course, complete science fiction, but maybe it's easier for us. There is no quantum, anything quantum here, and one can kind of think what these 5 people will do when they will be asked who they are. They will put in 5 different rooms with different numbers, and they will put some, what is the probability that I'm in room 3? They ask somebody. And if you know that there are 5 rooms, then he will say, oh, there are 5 people, I don't know who am I, they're all the same, so the probability of 1/5.
But
this is kind of
normalize mathematically all this reasoning to recover the result of an actual case. Because there you have some form of accounting system where you put a weight, and you said it cannot be equal probability.
Equal weight.
But if it's a phase, if you have to put a complex phase to recover some real scenario, then that's where it comes back from the back door.
The importance of many words, that word in principle can interfere, which I considered in this test of many words. But this is kind of in principle not relevant for this kind of experiment. We cannot in our laboratories to make words interfere. We don't have this technology. In the moment words do not interfere, their phrases are not relevant for us. So in all experiments which I consider kind of a realistic experiment which you do on Earth, and then you have these different outcomes. When you get 2 different outcomes, then a super beginner and it can kind of do with super technology, and then the phase important to him. But for us, when we don't interfere different outcomes, then the phase is not important. But of course, it's important if we consider the super technology which performs super experiments, which I think it's important to discuss the meaning of weight. Because I say the weight, bigger weight, stronger possibility of interference. And how you interfere? Because you use the phase. You want to interfere with this, you have to know the phase of particular word to interfere.
I understand the reasoning. Nevertheless, I would encourage to try to formalize, because I might be completely wrong, but my sense is that you might have an alternative formalism there, which whatever is the interpretation is extremely interesting to have. That's just a comment.
Okay, so just what I'm searching.
Branching and see how you recover. Do you see what I mean? It's a dynamical system, so you can formalize it mathematically.
What the experiment which I consider, they kind of fit. I don't see any problems there to require me to change, and I don't want to, you know, some people want to find new physics. I want to believe that the current physics explain everything, and I believe so. I want to feel that we understand the nature. And the only way to do this is to believe in many worlds, because all other theories do not look like they are right. This one might be right. It might be wrong. Maybe Néel tomorrow will find that it breaks down, but it might not. Clearly, some collapse theories, whatever, that are too ad hoc and to be true.
I think we should end on this note. I would like to add something, but it's really unfair, Lev, to say the last sentence you said at 6:10. But I think we will discuss this next week. So yeah, thank you very much, Lev. That was really nice, and thank you. Thanks to everyone who asked questions. Sorry, Aurélien, but I'm sure you will have plenty of time. And so yeah, bravo again. I guess next week again, complete anarchy. We just start from whatever we want. You two speakers can obviously start with a 5-10 minutes comment on, generally, preferably on either the other speaker or about, the issues that have been mostly discussed. If you want to clarify something or things like that, you don't need to do it, but if you want, you can. And that's all. I will send you the link for the recording that stops now on Monday, along with with the information. Maybe next week we're going to actually anticipate the discussion. That might be an option because nobody from the US was here, so maybe we can actually do at 2 or 3. I don't know what you think. Mostly, if it's okay with Lev and Paul.
So for me, better.
Better.
Fine with me.
Maybe we can do 3 so that at least we leave the option if they want to join, because it's not that early anyway for them, but it's better for us. Okay. Thank you, guys. See you next week.
Thanks.